Hello, hello, hello. All right, folks. So I'm recording these out of order, so forgive me if I say the first when this is not the first. But today we're recording the first half of a video over Sig-Figs. This is the second topic of the unit, and if you go looking for this worksheet, it is not worksheet 6.3. It is actually worksheet 6.2. This is what well, I'm not going to go into that. So first thing you have to wrap your head around with Sig-Figs, or significant figures, is that the word significant here does not mean important. That's not what we're trying to do here. Got a pop-up on my screen. Give me a second here. That's not what this is looking at. Significant here means reliable. Okay, it's how reliable is the number. It's how accurate is the number. How much can I trust the number that I'm looking at? And that is based on the number of Sig-Figs, or significant figures, which I will be abbreviating Sig-Figs. Something I want to say before we go too far into this is, and I told all my classes this here, you have to want to learn this. Okay, this is something that is somewhat niche. It's not exactly something you use in everyday material. This is something you have to want to understand. If you go into this and go, this is dumb, I don't want to have to do this, it will never click for you. You have to want to understand it. Okay? So, if you are willing to do that, this will come fairly easily. Now, I'm going to pause every once in a while and go off on a bit of a tangent talking into the why. Why is this? When is this? But for the most part, this is just a set of rounding rules that we are going to use when we start doing calculations, which is going to be the second video for this topic that I'm going to do. We'll be going into doing calculations with these numbers and how you have to use them to figure out when to round. But the whole purpose of the first half of this page is just to understand how many Sig-Figs do I have in the number that I'm looking at. Okay, so first off, there are three kinds of numbers. We have measured numbers, calculated numbers, and integers. Integers is a footnote that, well, actually, I'll go ahead and do integers now. Let's save some trouble. And it'll come up again when we get to temperature conversions later. Integers are numbers with an infinite number of Sig-Figs. And that's pretty much it. That will make more sense when we're doing temperature conversions. But integers have an infinite number of significant figures. Okay, that is because integers are numbers where that is exactly correct. That is the number. If I tell you that the number 2 is an integer, you can write it as 2 or 2.0 or 2.00000000000. It is an infinite number of Sig-Figs. We don't write any of the zeros or the extra digits because we know that it is an integer. Measured numbers are what we're mostly going to be working with in this video. And then we'll get into calculated numbers. You will see a couple of these calculated numbers as we go through this. But for the most part, we'll save... Sorry, someone's wandering around. Okay, I don't remember what I was saying. Calculated numbers we'll save mostly for the back. So for this, we're going to go into measured numbers. So without further ado, in general, if you are looking at a measured number, every digit in that number is considered significant. There is only one digit that is not always significant, and that is 0. Hang on a second. Okay, 0 is a number that is not always significant, and we'll deal more with 0 later. For now, the thing you need to know, if a 0 has a Sig-Fig on both sides of it, it is considered significant. Okay? So, using the information I have just given you, I want you to figure out how many sig-figs are in each of these 5 numbers? So pause this, write it down on the hard copy that you should have. All right, now I'm going to go through and tell you the answers. 27.32 is going to be 4. 37.9 is going to be 3. 8,720.47 is going to be 6, not 5, because that 0 has a sig-fig on each side of it. So the 2 and the 4 are both sig-figs because they are present. Therefore, the 0 also has to be significant. Same thing on 208.9. Okay, that 0 is considered a sig-fig. And then again, the 1.97, that is going to be a 3 sig-fig number. I'm realizing this is kind of hard to read, so I'm going to make this a little bigger. There, now I can actually read it while I'm looking at my computer screen, so hopefully you can see it a little easier. But yeah, so for these 4 numbers, 4, 3, 6, 4, and 3, that's how many sig-figs there are. And that's all we're doing on the front, is figuring out how many sig-figs there are in each of these numbers. Now, let's go on to our next rule. Some zeros are placeholder zeros. Okay, there are 2 kinds of placeholder zeros. Leading zeros, zeros that come before the number, and trailing zeros, zeros that come after the number. Leading zeros are never significant. Period. No takebacks. Leading zeros will never, ever, 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 ever be significant. Okay? Trailing zeros are sometimes significant. So, with that information now in mind, 0.12 has 1 leading zero, and then the numbers 1 and 2. Therefore, it has 2 sig-figs, because the 0 is a leading zero, so it is not significant, and then we have the 1 and the 2. So, pause this, write down how many sig-figs the other 4 have, and then I'm going to go through here in a second and tell you what the right answers are. All right, I'm going to assume you have done that. So, 0.0003 would be 1 sig-fig because all 4 of those zeros are leading zeros. 0.0042 would be 2 sig-figs because, again, zeros are all leading. And then 0.0123 would be 3 sig-figs. And then for some reason, 12.9 is also hanging out in this section. I'm not sure why. I don't remember why I did that. But this would have 3, and there are no zeros in it. So it really doesn't belong here. But yeah, 3. Hopefully you got that one. Now, the last thing to add. Sometimes we have numbers where we have significant digits and insignificant digits, or digits that we can trust and digits that we cannot trust. This is usually the result of rounding somewhere or a unit conversion. So when this comes up, when you have a number that has both sig-figs and insignifigs, or numbers that are significant and numbers that are not significant, both in the same number, we underline the last sig-fig. So in 7,000 here, we have 7000, and this middle 0 here is underlined. The fact that this 0 is underlined means it is significant. It is the last sig-fig. That means that this 0 is between the 7 and this 0, which is significant. Therefore, it must also be significant. So there are 3 sig-figs in this 4-digit number. Okay. Now, if you are wanting to know how this can happen, shoot me an email and I will try to explain it. But I want to keep this video as short as I can. So that is how you tell, looking at this, whether that is when the last digit is. So same thing. Go through, identify how many sig-figs in each of these. I'm going to give you the answers now. So 280, the 8 is underlined, so the 8 is the last sig-fig. The 0 is not significant here, so this is 2 sig-figs. Here we have 0.570. I forgot to mention this. I'm sorry. Question for you. This 0 right here, 570. Would you ever write that 0? Is there any reason for that 0 to be there? Well, yes, there is a reason, but in answer to the question, no, that 0 shouldn't be there. You shouldn't write that. Why would you write that? Well, you write it because it is significant. This 0 here is considered significant. The one in the front is not. It's a leading 0. It's never significant. But this trailing 0, we wrote it because it is significant. So this number has 3 sig-figs. Going down to this one here, 0.000300. All 4 of these leading zeros, insignificant. But these 2, we wouldn't have written them if they weren't significant. So this is a 3 sig-fig number. And then again, bringing up the rear, we have another number that really doesn't belong in this section, 2.06. That is going to be a 3 sig-fig number. Apologies for forgetting to go through this before having you work on that. So I hope that didn't stress anyone out too much. Now, to wrap up this video, here are 8 mixed numbers for you to identify the sig-fig count on. So pause this, write down how many sig-figs are in each of these numbers, and then I'm going to go through them here in a second and give you the correct answers. All right, 27, 2 digits, no zeros, 2 sig-figs. Simple. 29.6, 3 sig-figs. Again, pretty simple. 100.8. This one throws people for a loop. But both of these zeros are between a sig-fig here and another sig-fig here. So these 2 zeros would both be considered significant because they are between 2 other sig-figs. So this is a 4 sig-fig number. Next, we have 0.0054, 2 sig-figs. 2.00 is going to be 3 because we wouldn't have written those zeros if they weren't significant. 0.00570, those first 3 are leading. They do not count. This last one is trailing, and we wouldn't have it if it wasn't. So this is 3. This one's going to be 4 because this one has to be significant. We wouldn't have written it otherwise. 2 is significant. These 2 zeros are between these 2, so they're all significant. And then the last one here, 320, the 2 is underlined. That means it is the last sig-fig. So there are 2 sig-figs in this 3-digit number. That is it for this video. The next video will go through calculations, the back side of this worksheet. I wanted to make it 2 separate videos so that people who want to go back and look at the calculations can do so. That should make things a little bit easier on people. So I'm going to wrap it up here. I'll see y'all next time. Have a good one.